This is problem 4C. Y equals the log of this, and we want to find the derivative. If we use all the derivative rules, such as quotient, product, chain rule, it would be very hard. If we use some log rules, we can simplify this expression. Remember, ln means log ln of x. Well, that means log in base e of x. Something, special notation where e is a special number. In order to understand the rules of log or review them, let's look at this here. 2 cubed is 8. I can also write log of 8, and base 2 is 3. What are we doing here? We're going to rename or restate what we had before. Many statements in math, as well as English, can be reworded in different ways. For example, I can say Mary baked the cake. The cake was baked by Mary. Both statements are saying essentially the same idea, although there's a little bit of different emphasis. The first statement emphasizing Mary, second statement I'm emphasizing the cake, but the relationship that Mary baked the cake is the same in either way. So I'm saying the base number raised to the exponent of 3 is 8. So I say, here I'm saying I started with 2, I raised it to the third power, I get 8. Here I'm saying if I end up with 8, when I started with 2, what exponent must I have used? I had to use a 3. So here's the base numbers in blue, the exponent is 3, and the answer is 8. Here I start with a base number. Using this base number, if I use this exponent, I get this answer. I'm saying if I already had this answer, and I had started with this base, then what exponent did I use? It was 3. So logs are exponents. 3 to the 4 is 81. Same as saying 81 has a log in base 3 of 4. Log of 81 in base 3 is 4, meaning what? That I got to 81 by using the exponent of 4. Similarly, if I say b to the e is a, the log of a means what exponent got me there? The exponent was e. Now, just like there's rules for exponents, there's similar rules for logs. Look, x to the r times x to the s is x to the r plus s. When two numbers of the same base are multiplied, you add the exponents. So that you have a very similar rule here with logs. The log of r times s, when these are multiplied, is the log of r plus log times s. It's a very similar rule. It follows. Here we have a division rule. X over r, x to the r power over x to the s power is x to the r minus s. For exponents, the rule becomes log of r over s is equal to the log of r minus log of s. Finally, the last rule, it's not obvious why the rules are the same, but they are. X to the n power means I'm multiplying x out, using it as a factor, write it down a total of n times. Write it down n times, so when I have exponents, log of r to the n means it's n times this log. Now we go back to this concept over here. First thing I want to do is I want to simplify y. Before I can take the derivative, I'll use the subtraction rule to be the log of the top, 2x cubed plus 1 to the 4th power, minus the log of the bottom, the log of 9 minus 12x. Now we use that last rule, the multiplier exponent rule. This equals 4 times the log of 2x cubed plus 1 minus the log of 9 minus 12x. Now both these have x's and other numbers here, but I no longer have something being multiplied, or strictly divided, or exponentiated. So I have to stop here, and now I will take the derivative. So we'll use the chain rule. Try to remember the following, that the log of x, if f of x equals the log of x, so I can write f of x equals the log of x. If this is the case, f prime of x equals 1 over x. So we're going to call this thing w. We're going to call this thing, I'll do this piece first. I want to take the log of it, I want to take the derivative of this. So the derivative of this, I say f of x equals log of 2x cubed plus 1. I'll say equals log of w. So f prime of x, which is going to be df dx equals df dw times dw dx. Chain rule, where w is this piece. This equals df dw is simply 1 over w. dw dx is going to be 6x squared. Changing w back to 2x cubed plus 1, so I have 1 over 2x cubed plus 1 on the bottom. The top is 6x squared. I can write it next to each other. I can put it on top. using the same concept over here, I can call this thing g of x. I can say g of x, I'll call this z equals ln of z. So I can say dg dx equals dg dz times dz dx. So this is going to equal to dg dz, simply 1 over z. dz dx is going to be negative 12. So this equals negative 12 over 9 minus 12x. And I can simplify this by factoring out a 3 from the top and bottom, so it's negative 4 over 3 minus 4x on the bottom. Putting this piece and this piece together, we now say y prime equals, you need to have here the 4 in front, which I didn't have because I was only at this piece, 4 times 6x squared divided by 2x cubed plus 1, and this piece is going to be minus 4 over 3 minus 4x, and this can be simplified slightly. This equals 24x squared over 2x cubed plus 1 minus 4 over 3 minus 4x, and we are done with this particular part of the problem. So we'll move to piece D. Any comments you wish to make?
Nope, that's good.
Okay, I'm going to move to piece D. I'm going to erase
Erase
this
that
over here.
real quick. We're going to stay. No, it's not.